Hello everyone. I am Lakshmi Bhavani and my teammate is Sheila Sain. We are from Cybersecurity Department of CSC. Our topic is about first in first out page replacement. We did this presentation under the guidance of Dr. M. Prasad, Associate Professor, Department of CSC, SWAC. Now coming to the introduction, the first in first out page replacement algorithm is a popular algorithm used in operating systems which is used to manage memory more efficiently. It follows a simple principle, that is, the first page that enters is the first one to be replaced. Explanation of first in first out page replacement algorithm. In first in first out page replacement algorithm, a queue is used to keep track of the order in which pages are loaded into the memory. When a new page needs to be stored and the memory is full, the oldest page in the queue is replaced. No overallocation should happen in the page replacement. Performance should be good. Performance is calculated based on the number of page faults. Working example of first in first out page replacement algorithm. First we should find the location of the desired page on the disk and next find the free frame. If the free frame is found, continue and verify the page. If the frame is not found, select the victim frame and verify the desired page frame and replace it with the new page. Now let us take an example for FIFO page replacement algorithm. Here I took a small example 1, 2, 3, 4, 1, 2, 5, 1, 2, 3, 4 and 5. Here the main memory is having only 3 frames and it can hold only 3 pages at a time. To store another page, it has to be replaced with another page by following the concept of FIFO. At starting, the main memory is free. Now the CPU is demanding for page 1 that is not present in the main memory. Whenever the 1 is not present in the main memory, the control transfers to the OS, and from OS to the control transfers to the disk, and from disk we are getting the page 1 and place it in the main memory. This is a page fault because 1 is not present in the main memory. We are getting 1 from the disk. The page that is not present in the main memory, that we call it as the page fault. Now CPU is demanding for 2. 2 is not present in the main memory. So this is also a page fault. Next 3. It is also not present in the main memory. So it is also a page fault. Now we want to store page 4. The CPU is demanding for the page 4. This is not present in the main memory. Obviously it is a page fault, but already the main memory is full. Now it should be replaced the page which is no longer using. But using the concept of FIFO, whatever the first page placed in the memory, that is 1, is replaced with 4. From this we are getting 4, 2, 3. And we get 4, 1, 3 by following the concept of FIFO, and here we observe a page fault and next 2 and it is replaced with 3 by following the concept of FIFO and we get 4, 1, 2 and here also we get a page fault and next 5 which is not present in the main memory and it is replaced with 4 and it is also getting a page fault and next 1 it is present in the main memory and here we don't get a page fault and next 2 it is also present in the main memory and here also we don't get page fault. Next 3 which is not present in the main memory and it is replaced with 1 by following the concept of FIFO and here we get 5, 3, 2 and here also we get a page fault and next one is 4. It is replaced with 2 by following the concept of FIFO. Here we get a page fault and the last one is 5 which is already present in the main memory and here we don't get a page fault and total page faults here are 9.
Just now we see an example for page replacement. Now see the advantages of FIFO page replacement. FIFO page replacement algorithm is easy to implement and understand. There is no need for extra bookkeeping or data structure. This algorithm ensures fairness by giving priority to the page that has been in memory the longest. Now let us see the disadvantages of FIFO page replacement. B-Ladies anomaly. FIFO may exhibit B-Ladies anomaly where increasing the number of page frames can paradoxically lead to more page faults, making it less efficient compared to some other page replacement. No consideration of page usage history. FIFO doesn't take into account the history of page access. It might replace a page that was brought into memory recently, even if it is likely to be used again soon. Low cache hit rate. since it doesn't consider the actual usage of the pages. FIFO may leads to a higher cache miss rate. Now, the last disadvantage is thrashing. In situations where the number of page frames is insufficient to hold the working set of your process, FIFO may contribute to thrashing. Thrashing occurs when the system spends a significant amount of time swapping pages in and out of memory, resulting in poor overall. So, these are the disadvantages of FIFO page replacement. Now, let us see some real-world applications of FIFO page replacement where the FIFO replacement is used. It is used in supermarket checkouts. In a business supermarket, FIFO can be used to manage the queuing of customers, and it is also used at ticket counters. At a ticket counter, tickets can be distributed to customer using FIFO approach, and it is also used in printing queues. When multiple print jobs are waiting, a FIFO queue ensures fairness in printing order. Conclusion and recap of key points. In conclusion, FIFO page replacement is a simple and widely used algorithm, but it comes with its own set of limitations. It is important to consider the specific requirements and constraints of each situation before implementing this algorithm.
Thank you.